Alrighty, let's take a look at how we can factor some special problems that you come across in higher level math. Most of you are excellent at factoring trinomials, even when the leading term is 1. And most of you remember how to factor a difference of perfect squares. But sometimes we come across these other types of polynomials that you may or may not have ever learned how to deal with. And I'm just going to do a brief tutorial on how to handle that. The first one is when you're factoring a 4-term polynomial. So there are lots of different ways of doing this, but one of the most popular ways of handling this tends to be this box method or area model, where we have a box right here, and that box is subdivided into 4 smaller boxes. And the big box, though, is going to represent this polynomial. So notice this polynomial is made up of 4 parts. There's an x cubed, a 5x squared, a 3x, and a 15. And I'm going to put each of those 4 parts into the big box. And when I do that, I always like to put the first term, the highest power of x, in this upper left box, and the last term, the one without an x, in this lower right box. And we can put these two numbers, the 5x squared and the 3x, in either of these 2 boxes. It really doesn't matter. I'm just going to throw the 5x squared there, and I'm going to throw the 3x there. They're interchangeable. Now, what I'm going to do is I'm going to look at how I could find the area of this box by figuring out what this height along this side is and what the width of the base along this side is. Now, looking at these 2 terms, this x cubed and this 5x squared, I'm going to ask myself, what's the biggest thing I can pull out of both the 5x squared and the x cubed? And that answer is x squared. So what I'm saying is the length of this little part, that length right there, is x squared. Well, if that length is x squared, this is about to set off a chain reaction that's going to spill over into my entire factored form. If this length is x squared, how long does this length right here have to be in order for this little box to have an area of x cubed? Well, it would have to be x. Now, if this length right here is x, then what does this length down here have to be? So this box right here has an area of 3x. And that answer would be 3. So let's keep going. If this length right here is x squared, what does this length right here have to be in order for this little box to have an area of 5x squared? Well, the answer is 5. And finally, if this length is 5 and this length is 3, does this box here have to have an area of 15? It does. So that box provides my check. So what the box method has done is it's given me a new way to write the area of the big box, the x cubed plus 5x squared plus 3x plus 15, as a product of these 2 binomials. And so basically this thing factors into x squared plus 3 times the quantity of x plus 5. And you can do a very, very quick mental check by expanding this out. We have x cubed, check. X squared times 5 is 5x squared, check. 3 times x is 3x, check. And 3 times 5 is 15, check. And the last thing you want to do is look at each of these 2 binomials and see if you could break them down any further. And in this case, we cannot. So we have factored this 4-term polynomial. Now, let's take a look at a different type of problem. This type of problem here is a difference, because it's subtraction, it's a difference, not of perfect squares though, but of perfect cubes. So, how do we deal with this? Well, one way you deal with a difference of cubes is you still pursue the box method. Now notice that x cubed is the number x being cubed. And this minus 27 is the number negative 3 also being cubed. And one of the easiest ways to handle this, and there are lots of different ways you could go about trying to factor a difference of cubes, but again, most kids fall back on the box method or the area model. So this one looks a little different though. Notice instead of 4 squares, we're going to end up with 6. And you'll see why in just a little bit. So remember, the original polynomial was x cubed and a negative 27. So in the upper left-hand corner, I'm going to put in x cubed. That's my biggest power of x. And in the bottom right-hand corner, I'm going to put that negative 27. Now, when you factor a difference of cubes, the base of the first number and the base of the second number always create a binomial factor. So I know down here that I'm going to have an x minus 3 as one of my factors. That's one of the ways the difference of cubes will always consistently work. But remember, inside this black box, we should only have an x cubed and a negative 27. Now we're about to set off a chain reaction here, so follow closely. So if this side right here I'm claiming is a length of x, and this box here has an area of x cubed, what has to be the width of that box right there? Well, x times x squared gives us x cubed, so that box has to be x squared. And if this box has a length of x squared, and this box down here has a height of negative 3, then wouldn't its area be a negative 3x squared? Well, it would be, but here's my problem. Are we supposed to have a negative 3x squared in my original polynomial? Well, no, we're not. And I don't like that. So what I'm going to have to do is I'm going to have to find a way to cancel this negative 3x squared out up here in this box. And the way I'm going to cancel out a negative 3x squared is I'm going to put in a positive 3x squared. Because those are going to cancel each other out, and we're going to be left with x cubed minus 27, which is exactly what I want to have. However, this creates another consequence. Remember that we know that this side length right here is x. Well, what would this side length right here have to be if the area of this smaller box is a positive 3x squared and this length is x? Well, it would have to be a positive 3x, wouldn't it? Because positive 3x times x is 3x squared. And if this side length is 3x and this side length is negative 3, wouldn't that make this area negative 9x? But I don't want a negative 9x. All I want is inside this giant box is an x cubed minus 27x. So somehow I'm going to have to eliminate, I'm going to have to cancel out this negative 9x. And what cancels out a negative 9x? That's right, a positive 9x. Now, let's check what we have going on so far. We know this length right here is x. We know this area is 9x. So what would that make this length right here become? Well, it would become a 9. And if this length was a 9 and this length was a negative 3, doesn't that give me a negative 27? And when we look at the big box, don't these cancel each other out completely, as do these? So my factored form of x cubed minus 27 is x minus 3 times x squared plus 3x plus 9. I think this can be a little tricky, so I want to do one more, and I'm going to show you this one right here. I want to factor this, and I would ask that you pause the video when you try it on your own. Hey, welcome back. I hope you paused the video, and I hope you tried it on your own. So let's just do a quick check, and I'm going to go through this kind of quickly, so if you need to pause it, pause it. So first off, we know that 8x cubed is a perfect cube, And we know that 1 is also a perfect cube. So 8x cubed is the number 2x times itself 3 times. And 1 is, of course, the number 1 times itself 3 times. So this tells me that this number is 2x and this number out here is 1. And inside my box, I have to have an 8x cubed, which is going to go in the upper left-hand corner, and a positive 1, which will go in the lower right-hand corner. Now, let's kick off our chain reaction. If this length right here is 2x, what's this length here have to be? Well, it would have to be 4x squared in order to get that black 8x cubed that we're looking to get. And if this red length is 4x squared and this length is 1, then that would give me a 4x squared here. But I don't want a 4x squared. I only want what's written in black. So to cancel out that 4x squared in this diagonal box, I'm going to put a negative 4x squared, and it will cancel it out for me. Those two are now zeroed out. They're not there. Now, if this is a 2x, what would this length here be to produce this product? Well, it would have to be a negative 2x. And negative 2x times 1 is negative 2x. But doggone it, I don't want a negative 2x. So how do I get rid of a negative 2x? Well, up in this box, I have to put a positive 2x. That lets me zero out that negative 2x I had down here. Now, if this box is 2x and this length is 2x, then clearly this length right here would have to be a 1. And the last box provides our check. Is 1 times 1 1? Well, of course it is. So our final answer is this 8x cubed plus 1 does factor, and it factors into 2x plus 1. That's written down here, 2x plus 1, times 4x squared minus 2x plus 1. And that's written right here. And that's how you handle some of those special factors. So I hope that this helps you, and this might be some video you come back to and revisit later on as you see you encounter these factors again.